Good morning, guys. So last class we started trig identities and we started with review of some identities we already knew, which were the reciprocal identities and the quotient identities. So tangent and cotangent being sine over cos and cos over sine. So today we're starting some new identities which are called Pythagorean identities. Okay, and it should make sense to you why they're called that once we start doing these examples and how they relate to the Pythagorean theorem. Okay, so first note that our goal is to discover this identity right now. This is the first one we're doing, sine squared of theta plus cosine squared of theta. Okay, so our goal is to figure out what that identity is equal to. The first thing I want to make sure to point out to you guys with trig functions, sine squared theta means sine of theta squared. That's just how they write it for trig. Okay, so for example, if you have sine of x times sine of x, you would think that you would make that sine of x squared, but for the sake of saving time and not having to do the double parentheses, for trig, the squared just becomes before the x, and they mean the same thing. Okay, so when you see sine squared of theta, that really means you take the sine of theta, and whatever you get, you square it. Okay, so next, we're going to use this 3, 4, 5 triangle to write the trig ratios for sine of x and cos of x. Okay, so sine of x, opposite over hypotenuse. Here's x, by the way. That would be 4 over 5. Cosine of x is adjacent over hypotenuse, so we get 3 over 5. Okay, so now, if I want to know sine squared of theta, that means I'm taking 4/5 and I am squaring it. And cosine squared theta means I take cosine of theta, which is 3/5, and I square it. Okay, now remember, when you square something, it means multiply by itself. So 4/5 times 4/5 and 3/5 times 3/5. Remember, when you multiply fractions, you go across the top. So 16 and across the bottom, 25. And across the top and across the bottom, I get 9 over 25. Okay, and now we're not done yet. Remember, the directions were sine squared theta plus cos squared theta. So 16 over 25 plus 9 over 25. 16 and 9 is 25 over 25. Anything divided by itself is just 1. Okay, so at least for this example here, sine squared theta plus cos squared theta, or sine squared x plus cos squared x equals 1. Okay, so I've done that example for you guys. Now, you guys are going to do numbers 2 and 3, okay, and see what you get. And just please notice, number 2 has theta here, but number 3 doesn't have a clear x labeled. Call this one x, angle B. Okay, and it really doesn't matter if you chose to choose angle A as x, it would also work out. But for the sake of us all being consistent, let's use angle B as x. Okay, so you guys right now are doing 2 and 3, and then hopefully you can answer question 4 here for a hypothesis of what sine squared plus cos squared equals. Okay, once you finish that, move on to the next page. Okay, so pause the video now, work on 2 and 3. Okay, in a sec you can resume and move on to the next page. Okay, so now you should have finished the previous page, and now you're going to fill out this chart, which is basically we're taking an angle that we know from our unit circle, finding sine squared of that angle, cosine squared for that angle, and then adding them up. In this case here, we got 1. So I'll do the example for quadrant 2. You guys will have to do 3 and 4. So for quadrant 2, which I know is somewhere over here, of course, I want to choose an angle that I know. So I'll do, how about, let's call theta 2 pi over 3. Okay, I know that's in quadrant 2 because 180 is pi, which is 3 pi over 3. So that means 2 pi over 3. is right here, and it would have a reference angle of pi over 3. Okay, so now to fill out my chart with 2 pi over 3, first I need the sine of 2 pi over 3, and then we're going to have to square it because it's sine squared. Do the same with cos, and then we'll add what we get. Okay, so sine of 2 pi over 3, you guys should be able to do this still using your hand trick. The reference angle is 2 pi over 3, or excuse me, the reference angle is pi over 3, which is also known as 60. Okay, sine, you count the fingers underneath, if you remember your hand trick, and we get radical 3 over 2. Sine is positive in quadrant 2, so that stays as positive. Now, cosine is of 2 pi over 3. I know this will be negative because cosine is not positive in quadrant 2, only sine is. All students take calculus. Okay, but the reference angle is pi over 3. Cosine, I count the fingers above, so I get 1/2. Okay, but remember, these two columns didn't ask for sine and cosine, they asked for sine squared and cosine squared. So I'm going to square these now. Okay, and excuse me, this is a negative 1/2. Okay, so I have radical 3 over 2 times radical 3 over 2. Square root of 3 times square root of 3 is square root of 9, which just equals the whole number 3. On bottom, 2 times 2 is 4. Okay, now negative 1/2 times negative 1/2, so it times itself. Negative 1 times negative 1 is positive 1. 2 times 2 is 4. Okay, so sine squared of 2 pi over 3 is 3/4. Cosine squared is 1/4. Adding those up, 4 over 4 equals 1. Okay, so you guys have seen an example of what I'm looking for in this chart here. Now you guys complete this for quadrants 3 and 4. And your answers should be different. They shouldn't all be the same because you guys are going to pick your own angle in quadrant 3 and then your own angle in quadrant 4. All right, so pause the video now and work on 3 and 4. Please don't leave those blank because I left them blank in the video. You are responsible for finishing that chart. And now I'm going to move on to the next page. So pause it now, finish this chart, and then we will move on. Okay, so now we have discovered at this point that sine squared of theta plus cosine squared of theta equals 1. And that's a really important identity. So the first thing I want to say here is make a list of these identities somewhere in your notes. Okay, and that's really important. Here's why, because today we're taking the time to discover these identities and basically figure out why they are true. But moving forward, you guys should have this list of identities somewhere in your notebook that we already know that they're true, and you don't have to keep proving them over and over again. And when you take your quiz on this or your test, it's going to be an open note test, and you can just refer to your list of identities in your notes. Okay, so we're discovering these today, but then you don't need to memorize all of these. You should really have a running list of them somewhere in your notes. So this is the first one. Sine squared plus cosine squared equals 1 should be the very first identity on your list. Okay, so now one thing I want to do is just show that this identity can be written in different forms depending on what we solve for. Like right now, the 1 is by itself. But let's say I subtracted this cosine squared theta from both sides, right? Then I would get just sine squared theta on the left equals 1 minus cos squared of theta. Okay, it means the same thing. This is just, basic algebra. You can move things around as long as you add them both to one side, or add them to both sides or subtract to both sides. The golden rule of algebra: whatever you do on one side of the equation, you must do on the other. Okay, and then I could do the same thing subtracting sine squared and solve for cos squared theta, and that would be 1 minus sine squared theta. Okay, so these two new ones, these are not different identities. You don't need to make a separate one on your list of identities for those two. It's really just this first one rewritten. And the reason for that is I may give you something in this form. I may say, what does 1 minus sine squared theta equal? And you should be able to manipulate this first identity to get 1 minus sine squared by itself to determine that that is equal to cos squared theta. Okay, so these really just rewriting the original identity, which is that sine squared plus cos squared equals 1. Okay, now I want to discover a couple of the other identities. If you notice, we've only done sine and cosine squared so far. Okay, so now I want to do tangent. And the way I'm going to do that is, you guys know tangent is sine divided by cosine. So I'm going to take this equation here. I have sine squared theta plus cos squared theta equals 1. And I'm going to divide everything by cos squared theta. Okay, and again, golden rule of algebra. If you do it to every part of the equation, you are allowed to do that. So we divide all parts by cosine squared. Okay, so sine squared divided by cosine squared is tangent squared theta. Then I have cosine squared over cosine squared. Anything divided by itself is 1. Okay, and then 1 over cosine squared. Well, what's 1 over cosine? The reciprocal of cosine is secant. Okay, so on your list of identities that we talked about up here, number 1, okay, identity number 1 was sine squared plus cos squared equals 1. Here's number 2. Tangent squared theta plus 1 equals secant squared. Okay, make sure you add that now to your list of identities. Okay, and just like we did on number 1, I could manipulate this equation to solve for tangent or solve for 1. So the first thing, if you subtracted 1 from both sides, you could also say tangent squared equals secant squared minus 1. Okay, and then instead of subtracting 1 from both sides, I could also subtract tangent squared theta from both sides and solve for 1, which would be equal to secant squared theta minus tan squared theta. Okay, so with all of these, you can shuffle things around to solve for one thing in particular, but really these three are all the same identity, just looking different by moving things around. All right, and so now you have 2 identities on your list. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. Okay, now the last one, hopefully you guys could have guessed this. Now we're going to divide by sine squared instead of dividing by cos squared like we did on number 2. Okay, so sine squared divided by sine squared is 1. Cosine squared over sine squared, well, cosine over sine is cotangent. And 1 over sine is cosecant. Okay, so here is identity number 3. So right now, that list I was talking about, you should have a page in your notes of identities that you know to be true. You now have 3 of them. Okay, and remember, again, I can shuffle these around. So let's subtract cotangent squared. We could have 1 equals cosecant squared theta minus cotangent squared theta. We could also subtract 1 and say cotangent squared theta equals cosecant squared theta minus 1. Okay, all 3 of those are the same thing. And we now hold all of these to be true. We have proven them, and now you can use them. You can use these identities on a quiz, without having to reprove them. Okay, so right now we have our identities. You guys have copied these into your notes. And just so you are aware, your assignment is to complete page 4, it is. Okay, and then page 5 is going to be optional extra practice. Just so you guys are aware, this last page, page 5, optional extra practice for those who want it. Okay, page 4 here, I'll call your homework assignment. You must finish page 4 here. Okay, so it's like 6 problems. And I'm just going to give you a hint kind of on how to get started on some of these. So like number 1 here, secant squared x minus tan squared x. We want to simplify that. So I'm going to look to see if I can replace one or both of these to make some things cancel out. So first I'm looking at secant squared of x. Okay, so I'm going to go up to my identities we just proved, and where do I see secant? I see it right over here. Right here's secant squared of theta, or secant squared of x. And look, secant squared x is equal to tangent squared of theta plus 1, or tangent squared of x plus 1. So I can replace secant squared of x with tan squared of x plus 1. Because those two things are equal, we know that to be true, you can replace one with the other. Okay, and now I see I have tan squared x minus a tan squared x. Okay, so those tan squared x will cancel each other out, and it just equals 1. All right, so you guys finish the rest of this page, page 4, okay? And for each one, you're trying to find a way to replace some or all of the expression in order to simplify it, okay? And you're not reinventing the wheel here and doing all this discovery stuff. We've already done that. Now that you have these identities discovered, just go back and refer to them as you see each problem, okay? So cosecant squared x minus 1. I'm looking somewhere over here where I see cosecant squared to try and replace something and solve that one. All right, guys, so you have 5 more problems to finish. And if you have questions, please don't hesitate to reach out. I hope you guys have a great day.